Hello everyone, welcome to today's lesson. My name is Peter Emisa. Our topic for today is molar mass, mole, molarity and dilution. Most students are having problems when it comes to calculation questions under the molar mass, the mole, the concentration of the molarity and dilution. If today is your first time joining this class, don't forget to hit down the subscribe button to subscribe to my channel so that whenever I make a new video, you will receive a notification that Peter Emisa or Don Flavor has posted a new video so that you can watch and learn. Let's move on to our topic for today. Now, one may ask, what is molar mass? Now, the molar mass is defined as the mass of 1 mole of a substance. Now, this means the molar mass has a direct relationship between the mass, which is measured in grams, and the what? The number of moles or the amount of substance. Don't worry, we will come to calculations involving the molar mass, the mole, and the molarity and dilution. So let's take the molar mass first. Now, let's say we have to calculate the molar mass of glucose. So calculate the molar mass of glucose. So let's take, for instance, if you don't know the formula for glucose, sometimes it will be given the question, the formula, or you have to derive your own formula of glucose. So this means you have to know how you are going to get the formula of either glucose, sodium chloride, sulfuric acid, calcium sulfate, any compound at all given. If the formula is not given, you have to write the formula. Now, the formula for glucose is C6H12O6, like this. At the same time, I said when you are performing calculation on the molar mass, they are what the atomic masses will be given. So we take carbon, so something like this will be given. Carbon is equals to 12, hydrogen is equals to 1, then oxygen is equals to 16, like this. Then you solve. So solution. So we have to calculate the molar mass of what? Of this glucose. C6H12O6, like this. Now look at this. Carbon here is having 6 atoms. So carbon here is multiplying 6, like this. So carbon here is multiplying 6. Now we will have to add these elements together. We will add them. But before we add them, you can see that carbon here is multiplying 6. So carbon multiplying 6 here plus, so we are adding them, plus hydrogen here is multiplying what? 12. Hydrogen is also multiplying 12, like this, plus oxygen here multiplying 6, like this. So this means we will have to split the element. Now we split the element by adding them together, but don't forget, when you are adding them, if the number of atoms present in that element is 6, you have to multiply it by the element symbol. So carbon here is multiplying 6, hydrogen here is multiplying 12, then oxygen here is also multiplying 6. So you just do them, then you add them together. Now don't forget, we have been given each element and its value. So we have carbon here having 12, hydrogen here is also having 1, and oxygen here having 16. So in place of carbon, we can put 12 there. In place of hydrogen, we put 1 there. In place of oxygen, we put 16 there. So We just do it by carbon here is 12 like this, multiplying 6 plus hydrogen here is 1, multiplying the 12 plus our oxygen here, which is 16, multiplying the 6 like this. Then you move on to solve. So you just multiply this 6 and 12. So it's 72 plus 1 times 12 is 12 plus we have 6 and 96 like this. So we add them 6, 7, 8, 9, 10. So 0, then 1 here is 10, 11, this is 12, 13, 14, 15, 16, 17 plus 1, 18. So we get 180. Now, 180, you have to attach the unit. So for molar mass, its unit is grams per mole. So grams per mole. If you don't attach the unit, there will be a deduction of marks in an exam. You have to attach the unit so that the unit will tell you that it is indeed the molar mass you calculated for. So this is our molar mass of what? Our glucose. So our molar mass of glucose is 180 grams per mole. Now, let's take another question. So our next question is we are to calculate the molar mass of copper sulfate. CuSO4. So we have to calculate the molar mass of copper sulfate. Now, I said if the formula is not given, you will have to derive your own formula in the question. Now, I made a previous video on naming of binary compounds and let me say naming of compounds. Now, if you have no idea of how, now you should have an idea because you were taught way back. So if in case you have forgotten how to derive the formula of either copper sulfate, sodium chloride, magnesium nitrate, now all the compounds, if you have forgotten how to derive the formula for such compound, please, I have a video of how you are going to derive the formula. Don't forget to watch. Now if you watch, you gain more knowledge on how you are going to derive your formulas. So don't forget, this is Don Flavor channel. Hit the subscribe button to subscribe to my channel. You will receive more educating videos or educative videos. Let's move on. So copper here is 64, sulfur is 32, and we are taking oxygen as what? 16. So let's solve solution. So molar mass of CuSO4, which is molar mass of copper sulfate. So there is copper here. Don't forget we are splitting the elements one by one. But copper here, there is only one copper. So you can just write copper times 1, or 1, you are still going to get the same value. So copper, there is copper here. There is sulfur. Sulfur is also 1. Copper is 1. Sulfur is 1. Then there is what? Oxygen here. But oxygen here is what? Is 4. Oxygen here is 4 like this. So copper is 1. So 1, we don't normally write it. Copper is 1. Sulfur is 1. Oxygen is 4. Now don't forget, we have been given the atomic masses of such element. So copper is 64 here, copper here, we are taking it as 64. Please, these are fixed values. You can't change them. These are fixed values, fixed atomic masses. So copper is 64, sulfur is 32 plus oxygen here is 16 times 4 like this. So we are going to get 64 plus 32 plus 4, then 64 like this. Then we add these. So I have 4, 5, 6, we have 7, 8, 9, 10. So 0, 7, 10, then 6, 16. So 160 grams per mole. 160 grams per mole. So the molar mass of copper is 160 grams per mole. Let's take the next example. Calculate the molar mass of calcium chloride. Calculate the molar mass of calcium chloride. So calcium chloride. So here, I will not give you the formula direct. I will show you how you are going to derive the formula. Don't forget, I have a video on this. Go back and revise. Go back and watch. You are going to gain more insight on this. So calcium chloride. We know calcium is having a symbol of Ca. This is calcium. Now, calcium on the periodic table is an atomic number 20. This means if we are to write the electronic configuration of calcium, we are going to get 2882. So 2882. So first shell takes 2, second 88, then last shell takes 2. Now, this means calcium, because it is a metal, it is going to lose 2 electrons to become stable. So calcium here is 2 plus. Now, chlorine on the periodic table, element number 17. So let me write it here, 20 and 17. So 287. Now, chlorine needs 1 more in order to be stable. So chlorine will take 1 to become negative like this. So we are going to get Ca2 plus and Cl minus like this. So we are going to do what we call exchange of valency. So let me write calcium again, chlorine here like this. Now we transfer their valency. So there is 2 here, we forget the negative and positive. There is 2 here, the 2 comes here, there is 1 here, the 1 comes here. So we are going to get CaCl2 for calcium chloride. Now CaCO2. So it means calcium chloride is CaCl2. CaCO2. So we have to calculate the molar mass of calcium chloride. So we are taking Ca. So take Ca is equals to 40. Cl is equals to 35.5. So this, don't forget, these are fixed atomic masses. They are not going to change. It's better you know them. So molar mass of CaCl2. We have calcium and chlorine, 2 elements combined. So this binary compound. So calcium here is 1 plus there is chlorine here. But chlorine here is multiplying 2 like this. So chlorine here is multiplying 2. So calcium here is 40 plus chlorine is what? 35.5 multiplying our 2 like this. There is 40 plus, so 35.5 times 2. So first of all, let me do it. 2 times 35 is 70. 2 times 0.5 is 1. So you're going to get 71 like this. So we add them 70 and 30. I'm going to get 100 plus 10 is 110. So we are going to get 101 grams per mole. 101 grams per mole. So 111. Sorry. So you're going to get 111 grams per mole. Okay. So let's move on. Let's move on. Okay, so we are going to move on to the relationship between grams and mole, where we are going to combine our molar mass, our amount of substance, which is the mole, and our what? And our mass. So relationship between the mass and our mole. Relationship between the mass and our mole. Now mathematically, our n is equals to small m over our big M. Now, what is n? What is small m? What is big M? Our n is equals to amount of substance, which is also known as the number of moles. Amount of substance. So calculate the amount of substance. Calculate the number of moles is the same as n. Our m is equals to our mass. And our mass should be in grams. Then big M is our molar mass. Big M is our molar mass. So our N is equal to small m over big M. This is when we want to find our amount of substance in a particular compound. Let's take, for instance, if we are to calculate the amount of substance contained in 5 grams of calcium chloride. Now, we will have to calculate for the molar mass of calcium chloride. Then we are given our mass. So we use this formula to calculate our amount of substance in that particular compound using the mass and the molar mass. So N is equal to small m over big M. What if we want to find our mass? What if we want to find our mass? Now, this means we have to make M the subject. So here, we can do cross multiplication where this one will multiply this. So our N multiplying big M is equals to our mass. Now, we said our mass, our molar mass is having a direct relationship between the mass and the amount of substance. This is our molar mass. This is our amount of substance. This is our mass. So if we want to find our mass, we have to multiply our amount of substance times our molar mass. Don't forget, we now know how to calculate for the molar mass of any compound. Don't forget, we are going to use this from this scratch till we end, because we will move to our concentration, we also go to dilution. Let's continue. Let's take first example. Let's take our first example. One, calculate the mass of 0.5 mole of iron. So take Fe is equals to 56. So we have to calculate the molar mass of iron. Then the atomic mass of Fe has been given as 56. Now, whenever you get a calculation question in science, please don't forget to write down the parameters given in the question. So first of all, it says calculate the mass. So this means the question wants us to calculate for the mass. So just write mass. And the symbol is what? M. Please do it well so that the question will be very easy for you. Mass. You don't know. It says calculate the mass of 0.5 mole. Now 0.5 mole is the what? Is the amount of substance. That's why we said the amount of substance or the number of moles. So the 0.5 here is the amount of substance. So you can write mole or amount of substance. So amount of substance here, which is N, is equal to what? 0.5 mole. Then iron of iron. You have been given the atomic mass of iron. This means you have to calculate for the molar mass of iron. So molar mass, which is big M, is equals to, now you don't know the molar mass, so you have to calculate for the molar mass of iron, Fe. Now Fe was given as what? 56. Iron is Fe. So 56 is just the Fe. So 56 grams per mole. You put down your formula. Your N is equals to what? Small m over big M. You are finding for small m. You can just put in the values or you make M the subject, where M is equals to small n times big M, like this. You put in the values. N is what? 0.5 times molar mass. Where is molar mass? Big M, 56. 0.5 times 56. This. So we are going to get 28 grams. Don't forget, we said our mass is supposed to be in grams. Always our mass is supposed to be in grams. So our final answer is 28 grams. Let's move on to the next question. Question 2. How many moles are there in 50 grams of sodium hydroxide? Na 23, O 16, H is equals to 1. So how many moles are there in 50 grams of sodium hydroxide. This means we are finding for the number of what moles, how many moles. So they are asking you how many moles are there. So you are asked to find the number of moles. So number of moles or amount of substance, number of moles. N, we don't know. We have been given mass of the solution. Mass M is what? 50 grams, given the question. We have been given a substance which is sodium hydroxide, or a solution which is sodium hydroxide. Sodium hydroxide is NaOH. Please, if you don't remember how to do this, I have a video of how you are going to derive the formula. Please watch it. So, molar mass, big M, we don't know. So, molar mass of NaOH. So, it's sodium plus oxygen plus hydrogen. Sodium, we're given sodium as 23 plus oxygen 16 plus hydrogen 1. We are going to get what? 17, 7, 10, 2, 3, 4. So 40 grams per mole as the molar mass. We now have our molar mass as what? 40 grams per mole. But we know that our N is equals to small m over big M, right? Mass, we have our mass. Molar mass, we have our molar mass. We have to find our amount of substance. So we have to put in the values. Mass is what? 50 on 40, which is the same as 5 on 4, because this 0 can cancel this 0, of which we are going to get 1.25 moles. 1.25 moles. This means our amount of substance is 1.25 moles. Please don't forget your unit. Now, when we are writing the unit, we don't add E to it. So it is MOLS. MOLS. So 1.25 moles. So there are 1.25 moles of sodium hydroxide present. So 1.25 moles. Let's do the last example on the amount of substance, the mass, and so calculate the mass present in 2 moles of nitric acid. So H is 1, N is 14, O is 16. So we have to calculate the mass. So solution, mass M, we don't know. Amount of substance was given, or the number of moles was given. Amount of substance N is 2 moles. Then nitric acid, which is HNO3 or trioxynitrate 5 acid. So nitric acid is HNO3. So you have to calculate for the molar mass of HNO3, which is, this is the nitric acid. So molar mass of HNO3 is hydrogen here plus nitrogen here plus oxygen multiplying 3. Hydrogen 1, nitrogen 14 plus oxygen 16 times 3. So it's 15 plus 48. So 8, 9, 10, 11, 12, 13, 3, 4, 5, 63 grams per mole. So our molar mass is 63 grams per mole. We have to find our mass. Don't forget, our mass is equals to N times big M. I'm sure you now know how this came about, because N is equal to small m over big M. If you want to find this M, we multiply by Nm. So don't, please, if you interchange small m and big M, you are going to get a different answer. So note, our small n is equals to small m over big M. Small m over big M. So you can say, I usually call small madam and big madam. So our n is equals to small madam. Small madam comes first and big madam. So that's the big madam. So small madam and big madam. So n is equal to small m over big M. So our n is what? 2. 2 moles. Where is n? 2 moles times our molar mass is 63. So 2 times 63. 2, 3, 6. 2, 6, 12, 126 grams. 126 grams. So our mass present is 126 grams. Now we are done with our mole, our molar mass, then our mass. We are moving on to molarity, also known as concentration or amount of substance concentration, our molarity. Okay, so concentration or molarity, it is the amount of substance in moles per unit volume of a solution. So the amount of substance in moles per unit volume of a solution is known as our concentration or our molarity. Now, the volume of the solution must be in cubic decimeter or decimeter cube. This means our volume, which is V, should be in dm cube, which is decimeter cube or cubic decimeter. Now, to calculate molarity, we use the equation molarity or concentration is equal to our amount of substance over our volume. So our molarity or concentration is equals to, now our molarity or concentration is equals to our amount of substance, our amount of substance over our volume. Now don't forget, our volume should be in dm cube. Our amount of substance is in moles. Amount of substance, which is N, is measured in moles. Our volume should be in dm cube. Now, this means we are going to derive our formula as our concentration is equals to N on V. So our concentration, which is C here, is equals to our N over our V, where C is concentration, N is the amount of substance in moles, our volume in dm cube. We are going to get this whole unit as mole per dm cube like this. This means our mole is here, our dm cube, because it is dividing, it will be negative. If you don't write it as mole per dm cube, you can write it as mole per dm cube like this. So you can either write it like this, or you bring your division sign, then you bring dm cube. Any of these is correct. So our concentration is equal to our amount of substance over our volume. Now, what if our volume is given in milliliters or centimeters cube? What if our volume is given in centimeters cube? This means we will have to change it to decimeter cube. Okay, so if we want to change from either centimeters cube to dm cube, or milliliters to liters, or decimeters to liters, now this is the conventional unit we are going to use. Now we know that 1000 centimeters cube is equals to 1 dm cube. So 1000 centimeters cube is equals to 1 dm cube. Then 1000 milliliters is equals to 1 liter. 1000 milliliters is equals to 1 liter. At the same time, this 1 decimeter cube, 1 dm cube, is equals to 1 liter. 1 dm cube is equals to 1 liter. This means if I have 100 decimeter cube, it is the same as 100 liters. If I have 2 liters, it's the same as 2 dm cube. Now, if you have 1000 milliliters, it's equals to 1 liter. This means you have to change from milliliters to liters. The value you get in liters is the same as the value in decimeters cube. Now, 1000 centimeters cube is equals to 1 decimeter cube. When you are given your value in centimeters cube, you have to change it to dm cube. Now, let me give you an example. If I have 500 cm cube, it is equals to, now, x, because you don't know, we have to change 500 centimeters cube to dm cube. Now, what do I have to do? First of all, write down the conventional unit. 1000 cm cube is equals to 1 dm cube. So let me clean this one first. It's very simple. Let me write. Now, this means you have to know your conventional unit. So I'll write it down. 1000 cm cube is equals to 1 dm cube. They say I should find 500 cm cube in dm cube. So I am changing 500 centimeters cube to decimeter cube. So in the question, I was given 500 cm cube. I don't know my 500 cm cube in dm cube. So let me write x like this. After, just do it like this. So my conventional unit, I am changing from cm cube to dm cube. This is it. 1000 cm cube is equals to 1 dm cube. Now, let's say in the question I was given 500 cm cube. I want to change it to dm cube. So cm cube should be under cm cube. Dm cube should be under dm cube, because you don't know your value in dm cube. So you write it down like this. Now, don't forget, this one will cancel this one, right? Now, let me do cross multiplication like this. I want to find x. So 500 will multiply dm cube. So I'm going to get, okay, let me do this one first. 1000 will multiply x is equals to 500 multiplying dm cube, here like this. Since I want to find x, I said if you are finding for an alphabet, any number or any alphabet attached to what you want to find, you just have to divide by it. So I'll have to divide by 1000. I will divide by 1000. So this one will get rid of this. Then my x will be equals to 500 dm cube over 1000, like this. So if I punch 500 over 1000 like this, or you can just use your mind. So 500 on 1000, I'm going to get 0.5 dm cube, like this. Now this means if I am giving my value in cm cube and I want to find the answer in dm cube, what I'll have to do is to divide by 1000. Just divide the value in cm cube by 1000. So my 500 dm cube here, I'll have to divide by 1000. I'm going to get 0. And the value you will get should be in dm cube. So you're going to get 0.5 dm cube. So let's take, for instance, if you are given 50 cm cube to dm cube, it is just 50 over 1000. You're going to get 0.05 dm cube, like this. So if you are changing from the centimeters cube to dm cube, you will have to divide by 1000. Then you get your answer. Same as milliliters. If you are given 25 milliliters and you want to change it to liters, you will have to divide by 1000. Now if you divide by 1000, the answer you will get is the same as the answer in dm cube. Why? Because if you divide by 1000 and you get your answer in liters, you know that 1 liter is equals to 1 dm cube. So the answer you will divide and you will get it is the same as the answer in dm cube. So if I have 500 milliliters and I want to change it to dm cube, I'll just have to divide the 500 on 1000. If I divide the 500 by 1000, I am going to get my answer in liters, which is the same as in dm cube, because 1 liter is equals to 1 dm cube. So the answer you will get in liters is the same as the answer in decimeter cube. Now this is how we are going to do the learning. I will upload the video here, then you come here and watch. Then all our discussions, suggestions, questions, and everything will be on the WhatsApp platform. But if you also have a question, you can just write it straight here for me so that I will be able to see it. Very simple. But don't forget to subscribe to this channel. Click on the red button to subscribe so that whenever I make a new video, you can get access to it very easy without me telling you come here and watch. I've posted a video. This is how the learning is going to be. So I will just make a video. I will just post it because I can't send the video to the size is very huge, so I can't just make the video and send it straight forward to the WhatsApp platform. So I will just upload it. Then anytime we have the science lesson, you come here and watch. I'll give you the link. You come and watch. Then our discussions and everything will be on the WhatsApp platform or the Telegram platform. Thank you. Let's move on. Okay, so our first question on concentration of molarity is, what is the concentration of a solution prepared by dissolving 6.0 grams of sodium chloride in 500 cm cube of a solution? So it says, what is the concentration? This means we are finding for our concentration. So let's start solving it. So what is the concentration of a solution prepared by? So concentration, C, we don't know. prepared by dissolving 6 grams. Don't forget that 6 grams is your mass. So mass 6.0 grams. Now we have been given volume here. So volume V is in what? cm cube. Don't forget to change it to dm cube. So we said we are going to divide by what? 1000. So we are going to get 0.5 dm cube. So this is our volume here. So I've changed my volume to decimeter cube. Let's continue. Now it says sodium chloride in 500 cm cube of a solution. Now we have to know our atomic mass. Sodium is 23. Our chlorine here is 35.5. This means we have to calculate the molar mass of NaCl. Concentration is a mix of the molar mass, the volume, the amount of substance. So we are going to combine all our formulas. So that's why I started with the molar mass, the mole. So it is in order. So molar mass of NaCl is Na plus chlorine, which is Cl. So molar mass is 23 plus what? Hey, chlorine is 35.5 like this. Chlorine here. So we are going to get 58.5 grams per mole. 58.5 grams per mole, which is our molar mass. Now we are asked to find concentration. We know that C is equals to N over V. So let's check whether we have all the parameters given the question. Concentration is what we are finding. Our amount of substance, N was not given in the question. Our volume, where is volume? Volume was given in the question. So this means we have to look for a way to find the amount of substance. We have to find our amount of substance, which is N. But we also know that our N is equals to small m over big M, like this. Now, the amount of substance here is the same as the amount of substance here. So if you don't know this, you can use another formula to find the N. You know that N is also equal to small m over big M. So let's check whether we have small m and big M here. Where is small m? 6. Big M, where is big M? 58.5 grams per mole. N is equal to mass is 6 on molar mass, 58.5. So N is equal to 6 on 58.5. So this is 0.10. So 0.10 what? Mole. 0.10 mole. Or 0.103. 0.103 mole. So we now have our amount of substance. So let's find our concentration. C is equal to N over V. Our N, where is our N? Our N is 0.103 on our V. V is what? 0.5. 0.5. 0.5. So we are going to get our final answer is what? 0.103 on 0.5. We are going to get 0.206. 0.206. 0.206 mole per dm cube. Please don't forget your unit.